Hey guys. So I wanted to do a couple quick examples. Okay. Okay, so let's see. Let's say that we have a basis B, and this is going to be the basis. I don't know. 1 minus 1, and then the second vector is going to be like um, a half one, something like that. Okay. And then, right, and then I'm gonna say that I have a matrix. My matrix, um, let's say it's gonna be like 0, a 5, a 1/2, and -2 or something. Okay. And we are given, so this is a basis of R2. And then this is the, A is going to be the matrix of some linear transformation T relative to this basis B and B. Okay. Okay, and now we have to find T. Okay, so what do we do? Well, first of all, each of these columns tell us something. So the first column says that when I plug in T of 1, -1, the result has coordinates 0 and 5 relative to this basis. And well, that just means that it's 0 times the first vector plus 5 times the second vector. Okay, that's T of 1, -1. And what about T of half 1? Well, the second column is a half -2. So that means that the coordinates of T of half 1 are, the first coordinate is a half, second coordinate is -2, and the coordinates are relative to this basis B. So we plug those in. Okay, so we have -2. Okay. These are just some vectors, so therefore we know what is T1 -1. That's just 5 halves, 5. T of a half 1. Well, that's just a half minus 1. That's -1/2. -1/2 minus 2. Right, that's -5 halves. Okay, and now to really find what T is, we have to know, like, let's say T of AB. Okay, well, since we know T is linear, all we have to do is write this vector AB in terms of 1, -1, and a half 1. So let's try it. In other words, we have to find the coordinates of AB relative to this basis. So if we are finding coordinates, this is what we have to do. Let me just make sure. I have to find the coordinates relative to AB, or sorry, I have to find the coordinates of AB relative to this basis. So I reduce. And then oops, what about that? Okay, this minus a half that. Okay, so these are the coordinates. So that tells me that this vector AB is just 2a minus b over 3 times 1 negative 1 plus 2a plus 2b over 3 times a half, oops, a half, comma 1. Let me make sure, yeah. Okay, and now, you know, if you want, you can check that 2a minus b divided by 3 plus 2a plus 2b divided by 3 divided by 2. So that'll be a plus b over 3 plus 2a minus b over 3. That'll be a. And similarly, this plus this will be b. And okay, so now apply t to both sides. So t of ab, let's just 2a minus b over 3 times t of 1 negative 1 plus 2a plus 2b over 3 times a half 1. And we already computed what is t1 negative 1. That was 5 halves 5. And then the other one, t of a half 1. Oops. It's a t in there. T of a half 1 was negative a half, negative 5 halves. Is that right? Yeah, okay, that's fine. I mean, if you want, you can simplify from here, but I mean, that's fine. Okay, so now we've reconstructed t given what some matrix of t was. Okay. And that is fine.